For decades, Alzheimer's has felt like this thief that just shows up in the night. We know it's a possibility for some of us, but the big agonizing question has always been when.
So many families, researchers, and of course patients have been living with this cloud of uncertainty. We've gotten pretty good at spotting the signs of Alzheimer's in the brain, sometimes years, even decades before any symptoms actually show up. But that knowledge, it's always come with this giant question mark hanging over it.
Well, what if we could change that? What if a single blood test could actually start to predict the future? Okay, let's really dive into this, because a new study is suggesting we might be on the verge of turning that big question mark into something that looks a lot more like a timeline. And this could completely transform how we fight the disease.
To really get why this new research is such a big deal, you have to understand the problem that scientists have been banging their heads against for years. It's not about if the signs are there, it's all about when things will actually start to happen.
And this slide really gets to the heart of it. On one hand, our current tools can tell us if someone has the underlying brain changes of Alzheimer's. But the big challenge has always been we can't predict when the cognitive symptoms will actually kick in. Think about it. Knowing you have the markers is one thing, but living for maybe 5, 10, even 20 years before symptoms might start, that's a whole different level of uncertainty. And for scientists trying to run clinical trials, it's a huge problem. How can you test a drug that's supposed to prevent something if you have no idea when that something is supposed to happen?
This huge challenge is exactly what sent scientists looking for a better way to predict the future. Not a crystal ball, right? They needed a real biological marker, a biomarker, that couldn't just say yes or no to the disease, but could actually track its progress. And it turns out, they found a really powerful clue right there in our blood.
So, let's meet the star of the show, p-tau217. Now, this is just a specific form of the tau protein, which you probably know is one of the main players in Alzheimer's. But here's what makes p-tau217 so incredibly special. Its levels in your blood don't just flip on like a switch. Instead, they rise slowly, steadily, and predictably as the disease progresses in the brain, long before symptoms show up. It's less of a light switch and more like a dimmer switch that's gradually being turned up. And that slow, steady increase, that's the key to this whole thing.
So the researchers have this p-tau217 data, and they do something just brilliant with it. They don't just track the level. They use it to build a totally new kind of timeline, a timeline that isn't based on how old you are, but on how far along your disease is. They call it a disease clock.
And this quote from the study really nails it. It says, unlike general biological agent clocks, clock models track disease progression with a specific biomarker. See, this isn't about your chronological age, how many birthdays you've had. This clock is measuring disease time. It basically hits a reset button for every single person, starting their clock at the exact moment their p-tau217 levels hit a certain point. This lets you compare everyone's journey, apples to apples.
And this is the aha moment. Visually, just look at this. On the left, you've got the data plotted by a person's actual age. It's just a chaotic mess, right? You can't see any real pattern. But now, look at the right. This is the magic of the disease clock. By lining everyone up based on their year 0, the year they tested positive for p-tau217, all that chaos just snaps into this clear, predictable line. It's the exact same data, just seen in a whole new, much clearer way.
All right, so now we have the clock. What does it actually tell us? Well, this is where it gets really, really interesting.
So the first question is, okay, how accurate is this thing? Well, the model was able to predict when symptoms would start with a margin of error of about 3 to 4 years. Now look, for you or me trying to plan our lives, that's still a pretty big window. But for a researcher designing a clinical trial, that is an absolute game changer.
But that's not even the most surprising part. The really fascinating discovery was about what controlled the speed of the clock. It wasn't what you might expect, like genetics or other health problems. The single biggest factor was how old a person was when their disease clock first started ticking.
Yeah, check this out. The researchers found that if someone's clock starts ticking, they test positive for p-tau217 at age 60, they have on average about 20.5 years before symptoms show up. But if their clock starts at age 80, that window shrinks like crazy, down to just over 11 years. The disease literally seems to move almost twice as fast in older people. It really suggests that an older brain just might not have the same resilience to fight back.
Okay, so let's bring this all together. What this means now. A tool for today, hope for tomorrow. What are the real-world takeaways from all this? What can we do with this clock right now?
Okay, so how does this change the game? First, And this is huge. It could totally revolutionize clinical trials. Researchers can now pick people for studies who are most likely to develop symptoms soon, making those trials way faster and more powerful. It also creates a standard timeline so we can track the disease consistently across thousands of people. And the concept works with a bunch of different blood tests, which is great. But, and this is a really, really important but, it is not ready for personal use. Not yet. That 3 to 4 year margin of error is just too wide for a doctor to use it to make decisions for an individual patient.
And hey, don't just take my word for it. The researchers themselves are super clear about this. They say straight up that testing people without symptoms is not recommended outside of a research study. The potential for causing stress and anxiety is very real, and the science just isn't precise enough yet for your doctor's office.
So, where does that leave us? Look, this disease clock isn't some magic crystal ball, but it is an incredibly powerful new map. For the first time, it lets us see the path of this disease more clearly than ever. And when you can see the path, when you understand the timeline, well, that gives you a much, much better shot at actually changing the final destination.